In this video, we'll be taking up the homework on transformations. So to be honest with you, this sheet was pretty repetitive and it took me quite a while to do, but it's good practice just because it has been a while since you've done transformations in grade 11. So for the first question, they just want me to state the parameters and describe the transformations. For number 2, same thing, state the parameters, state the transformations. For question 2C, for 2C and 2D you have to do some factoring. So just make sure K is factored out, because otherwise you'll state the horizontal translations incorrectly. For question 3, they ask us to match the graph with the equation. So I use my knowledge of end behavior and symmetry to match up with the graphs, but you could have, there's lots of other ways to go about doing it. For question 4, they wanted me to state the transformations and write the equation of the transform function. For question 5, I stated the transformations, and they wanted me to also state the domain, range, the vertex, as well as the axis of symmetry. Now, I don't like the wording for vertex. I would prefer if this was global. Let's see, this is a opening up. This is a global minimum point. I would prefer if they just said the location of the global minimum point. Because vertex, I would reserve the word vertex for parabolas. I wouldn't use that word for quartic, even though I understand what they're trying to say. Okay, for question 6, basically we're stating transformations again, and they want me to graph the transform function. Now what I did instead was I gave you the points of the transform function, and you can go ahead and plot them. You can use decimals to check your answer as well. But if you have the points, I'm very confident that you can connect the dots. I also gave you the domain, the range of the original, and the transform function. So 6A and 6B was pretty time consuming, but it's good practice. Oh, and of course there's 6C as well. So 6A, B, and C, I would argue is a very good practice. For question 7, they wanted us to write the equation given the transformation and then state the domain and range. And if it is an even function, even degree power function that we're transforming, they wanted us to tell them the absolute maximum point or minimum point, as well as the axis of symmetry. So I like this wording a lot better. So for question 7, they didn't use the word vertex, which I would agree with. I personally reserve the word vertex for quadratics. If it's not a quadratic, I say it's absolute maximum point or absolute minimum point. Okay, so that's the homework on transformations of power functions.